So next up in the tech track is Lilly Ryan from Australia. So she's hands down the speaker with the longest trip in this room, or in this conference. Lilly's a very interesting person, active in a wide set of different communities. She's an Australian penetration tester. She's very active in the Python development world. And she has an ability to take practical problems and put them in a wider context. From my point of view, she's adding a philosophical dimensions to these problems. And when I first heard her talk, this blew me away, and I knew immediately I want her to speak at Swiss Cyberstar. The only barrier was, well, Christian, you like this, but will the audience also like this? So it's always a bit of a balance. But then, when I learned that she's doing my biometrics, facial recognition, I realized, now, this is a perfect fit for our trust topic. And this is something that I'm sure that you guys will be very interested as well. So please welcome Lilly Ryan from Australia.
Welcome back from lunch, everyone. My name's Lilly Ryan, and today I'm going to teach you how to disappear completely. I'm an ethical hacker from Australia. You can find me on Twitter as Atticus_AU if you like. In a previous life, I was a medieval historian, I was a linguist, I was a graphic designer. But these days, my job is to push the boundaries of systems. The systems that I like to interrogate the most are not just networks and web apps, but also the social systems that govern how and when technology gets used. I'm especially interested in the non-consensual use of technology in public spaces and how we can make these things more visible to the public and challenge them when we find them. So today, we're diving into one of the more thorny and increasingly prevalent examples of non-consensual public tech use. This is facial recognition technology. So over the next half an hour, I'll show you how this tech works, where it gets used, and how it can be broken. We'll also talk about why it's important to keep being critical of facial recognition technology, even though the GDPR promises to make it harder for this tech to be used without your informed consent. So let's start with the science fiction version of facial recognition. This is the intro to the American television series Person of Interest. There's all this high-tech, sci-fi face detecting going on. We're connecting faces with identities, interpreting moods, linking phone call metadata. It's great fiction, but reality has already stepped over this threshold. You may have seen this clip before. In September last year, this clip of traffic surveillance cameras at a Chinese intersection turned up online. And because we live in the era of fake news, it's easy to be skeptical about short video clips that claim to be unveiling near-futuristic tech. But this is actually real software running on a live system. Here's a better video of that same software. The labels are in English this time instead of Mandarin, but it is still probably a bit too small for you to read them from where you are. So let me tell you what it's doing. It's detecting the basics of things in the video stream in front of it. Is this thing a car or a bicycle? Is it a pedestrian? Is it a van? If it's a car, for example, what color is it? You can also see it highlighting the paths there that everybody's taking. And it also tries to detect whether things are a vehicle, person, etc. And it will track that path regardless. And if it thinks it sees a pedestrian, it starts describing what it thinks they're wearing, it identifies the gender that it thinks somebody is, it gives an approximate age for the person. You know, is this a child, is this an adult? And having access to this kind of capability makes it really easy to track somebody around a busy city, even in a country like China that has a population of over 1 billion people. And you can see at the sides where it's pulling out images and timestamping them that it's going to store and compare them to later. So SenseTime, which is the company that makes this software, have another product which is called SenseFace, which does exactly what it says on the tin. SenseFace picks up live streams from cameras at places where people will pass through with their faces clearly visible. These are places like escalators or train station ticket barriers. So their software matches the features from the faces that they detect in these streams to information that they already have on file. As some of you may know, the Chinese government requires an ID card for all citizens above the age of 18, which is also what the algorithms that underpin this technology were trained on. So there's not only a ready-made government database that the system can link into, but it's highly accurate because it's almost certainly seen every single one of these faces before. And I know that it can be easy to look at this and dismiss it because we hear a lot that the general attitude of the Chinese public to things like privacy and surveillance are fundamentally different to attitudes in many other countries, but systems like this absolutely get used in many other places. The United States in particular gives us many egregious examples. And this isn't just because Silicon Valley keeps coming up with new things that it decides to embed facial recognition tech into, but also because that country has this diversity of state-by-state laws that have led to some really extreme use cases. So one among the many things, for example, that Amazon has been criticized for this year is for selling cheap access and consulting services to local US law enforcement agencies who wanted to use its recognition API. So at a time where people are unjustly targeted every single day by law enforcement in the United States and in many other places, just for the color of their skin, hearing that yet another closed-source proprietary algorithm is being mixed into law enforcement processes without any apparent oversight, this is a real concern. And it's partly because of things like this that a lot of the loudest critical and ethical research into facial recognition technology also comes from the United States. This is Joy Paulin Weenie. She's a researcher at MIT Media Labs, a hell of a poet, and she's campaigning hard for more transparency around how accurate facial recognition algorithms are. In 2015, Joy founded the Algorithmic Justice League to raise awareness about social biases that are built into facial recognition tech. She started it because her own research projects into facial recognition technology and augmented reality were extremely difficult for her to finish, because every single time she tried a project, she was running into algorithms that were trained on heavily biased data sets that failed to recognize her dark skin as a human face over and over again. In order to get her work done, she had to resort to holding a white mask over her face or to get some of her lighter-skinned colleagues to perform these demos. And in December last year, under the umbrella of the Algorithmic Justice League, Paulin Weenie published a comparative study of the accuracy of 3 commercially available facial recognition APIs. She looked at Face++ out of China, Microsoft Azure's Face API, and IBM's Watson. And she found that there was an overall trend towards accuracy, but only if you were a lighter-skinned, male-presenting person. And there were many more false matches if you were a darker-skinned or a female-presenting person, or especially if you were both of those things. Her work also highlighted just how opaque a lot of these algorithms are. While everyone's running around closing off these algorithms and data sets that make up this secret source facial recognition product, almost nobody is independently auditing any of these things. Most of the statistics that we have about how accurate any given facial recognition API is come from the companies themselves, which isn't science, it's marketing. And when this kind of tech gets sold to third parties and used to make decisions about who should be arrested or who should be detained, there's no real recourse for any kind of justice. And it's not just bias based on skin color. Late last year, a pair of researchers from Stanford University published a study that claimed to be able to use facial recognition to detect whether or not somebody was homosexual or heterosexual. So I yelled so loudly when I read this paper that one of my neighbors came over to see if I was okay. Because while the algorithm absolutely does take pictures of human faces and assign them a rating of gay or straight, the way that the algorithms underneath were set up completely ignored the idea that anybody might be bisexual or asexual, or that gender exists on a spectrum instead of a strict binary. And yet, all over the news, people were talking about this particular study as if it was some kind of magic, scientific, facial recognition gaydar, instead of questioning what really sounds like pseudoscientific phrenological nonsense. Nobody really questioned it because, well, mostly because it used phrases like facial recognition, machine learning, lots of buzzwords, and so of course, it must be cutting edge, and it must be accurate. But it isn't just law enforcement agencies and headline-grabbing research that uses this kind of tech. Facial recognition is used in marketing and advertising contexts far more often, and many times with even less scrutiny and public awareness or oversight. So this, for example, is the maintenance interface of a digital advertising screen from a shopping mall in Canberra in Australia. This was taken in October last year, and you can see it there detecting the faces of the two people standing in front of it. In Australia, it's extremely common for digital advertising screens to do this kind of thing. A lot of them are equipped with cameras, and they're pre-installed with tracking software. This one here is running one from the French company Quividi. So companies like this, they specialize basically in commercial applications of facial recognition tech. So the Westfield Corporation, which operates the shopping mall where this screen was found, runs many other shopping malls across Australia and Europe and North and South America. And using advertising screens like this, they detect what they think is your age and your gender and your mood. And then they correlate this information with data from your smartphone as it pings off all these complementary Wi-Fi routers around their malls to make a real-time map of where people are and what advertising they should be showing, to track suspicious people for security incidents, to work out whether they can sell them anything else. When the Australian public found out about this last year, a spokesperson for Westfield was asked for comment, and she said that Westfield does this to connect customers with retailers in a more meaningful way. I'm not actually sure what that sentence means, because as someone walking around that mall, I don't feel a special relationship to anybody, especially if I don't know that this kind of tracking is happening. Connections is a two-way thing, and if I'm not participating, it's not a connection. But Westfield isn't the only retail operator who does this kind of thing inside shopping environments. So in May this year, a New Zealand supermarket chain also got a lot of press when it came out that it was using facial recognition technology in their stores to try and detect shoplifters. And this only came out because they used this tech to apprehend a visitor to one of their supermarkets who, it turned out, wasn't the shoplifter that they were after. It was just some guy going to get milk. So this cutting-edge technology got a lot of bad press for being used to persecute people for crimes when it clearly didn't work very well. But even more than that, people were angry that this kind of technology was used every time they stopped by to get some bread, and they weren't informed about it. Even churches have been getting in on the facial recognition action in the last few years. There's a whole subset of the industry dedicated to making it easy to know just who has or has not been going to talk to God this week. But at its core, facial recognition tech is just trying to answer this one question. Who is this particular person in front of the camera right now? The problems come when we overlay different meanings on that answer. You know, the question of who is this can seem either benign or threatening when we look at it through the lens of law enforcement or marketing or religion or sexuality or any number of other applications. Sometimes facial recognition makes life easy for us. Quite often it comes at the expense of being invisibly surveilled without being told about it. And depending on who you are, and where you are in the world and where you are in life, and how political factors are working for or against you at any given point in time, the thing that was convenient today can be threatening tomorrow. But without questioning the convenience and pushing the boundaries of the assumptions that we make about this technology, that infrastructure will remain there with the potential to become a threat at some future point in time. And facial recognition tech is often marketed as something that helps us to trust that a person is who they say they are. But given what we know about how many different facial recognition products exist and how little any of them are actually independently audited, how much can we trust facial recognition itself to be accurate? How much can we trust that the facial recognition that's used in the spaces that we inhabit won't one day turn their algorithmic biases on us? The good news, for given value of good, is that plenty of people, from artists to academics to fashion designers, they've given a lot of thought about how to circumvent these technologies. And we can do this ourselves today. But to do it properly, first we have to understand how facial recognition tech works. Like we've just established that facial recognition technology is a broad umbrella term that covers a lot of proprietary implementations and algorithms and approaches, as well as a handful of open source solutions. But although every company's solution looks a little different under the hood, they all operate using roughly the same 3 steps. And these are detection, face print creation, and recognition. So before a system can recognize a face, it needs to know that it's looking at a face. That's what detection does. Traditional computer vision facial detection is all about patterns, the maps of light and dark parts of an image, and the patterns that are formed in a human face by the eyes and the nose and the mouth. This is a representation of the Viola-Jones object detection framework. This is a fairly commonly used system for detecting faces that are present in an image. It detects patterns of dark and light relative to the patterns next to them, and it refines its model over a few iterations. It's fairly crude pattern matching, and it needs a full frontal image of the face in order to work, but it does work fairly well with those limitations. And this is what most phone cameras will use to detect a face and put a box around it when you're taking a picture. It's pretty cheap. It doesn't take much processing power. The next step is face print creation, which helps systems to get a more accurate map of a human face from a two-dimensional image. Traditional facial recognition tech generally does this by creating a mesh. This measures things like the distance between the eyes, the width of the nose, the depth of the eye sockets, the shape of the cheekbones, and the length of the jawline. So quite often it begins with a generic model of human facial proportions. It's trained on lots of different photographs of people, and then it's averaged out. And then this average model is placed over your face, which has already been detected by the system, and the dot points are then adjusted to fit the edges of the dark and the light patterns on your face. Then this model's refined by relating the dots to one another. That creates the mesh of your face. And that can track you as you tilt and you move when you aren't looking directly at the camera. But as I said, this isn't the only way to do it. Newer methods take some different approaches. This is what the iPhone's true depth camera sees. So the iPhone, when you use Face ID, it projects an array of 30,000 infrared dots over your face to get a real-time sense of depth in front of the camera. This is just one frame of data from those sensors. When it takes a capture, it takes many frames of data in real time, and it compares them to each other to get a 3D map of your face. So once the system has a map of the face, it can try to recognize it. Recognition connects all of this info with the other data that the system already has about you. So in the case of the iPhone Face ID, you have to register your face first, and then it stores that information to compare new data against. And a numerical representation of a mesh pattern might be compared against other mesh patterns in a different database, like a government database. Some recognition approaches are a bit different. Some of these earlier steps might be skipped in favor of a different machine learning approach, which happens after it detects a face. For example, Facebook's facial recognition algorithm is called DeepFace, which is a great name. And this is what it uses, or in the jurisdictions that it's allowed to, at any rate, to auto-tag you and your friends in the images that you upload to the site. And this method is apparently 97% accurate, although that is according to Facebook themselves. So again, this is marketing, this is not science. Another approach, which is used by things like the Python face recognition library, uses a pre-trained deep convolutional neural network to do the detecting and recognizing of a face. It will still take photographs of people's faces, it'll do a bit of mesh creation, and it'll skew them until the system has some kind of average, like what the face recognition library's done to this picture of Will Ferrell. And then, the neural network takes 128 separate measurements of the face. These measurements correspond to, actually, we don't really know. The neural network kind of decides for itself what it wants to measure, however it does that, and whatever happens, it comes up with these mysterious 128 numbers. It may win you the lottery, I don't know. And these measurements are unique enough to be used to identify people when the camera sees them again, because the network can run the same calculations and cross-correlate. I've tested out this library by training it on a picture of myself. It was spooky how quickly it would still recognize me, even when I was wearing a mask, or a fake beard, or pulling a silly face. Which leads me to my next point. How do we mess with these things? This depends on whether you want to mess with facial detection and stop this at the source so it doesn't know that a person is there, or face print creation, so the record of your face that's created now doesn't match the, whatever your face looks like in a few seconds or a few minutes. Or whether you want to mess with facial recognition, where you try to stop a system from recognizing that this is you specifically. And the focus of the adversarial methods that I'm about to discuss in just a second, they're on the physical layer of attack. So that means how facial recognition systems can be attacked by a person standing in front of a camera, much like I am now. So if you do further reading on this, you'll also read about attacks that focus on the digital layer. And that's by altering recognition information in a database so that it presents false information, for example. And I find that part just as fascinating, but I've only got half an hour with you, so we'll leave that to the side. And there are also other fields of study and other biometric recognition attacks like gait analysis, iris scanning, fingerprint spoofing. These all deserve their own talks. But again, clock's ticking. I am happy to chat about all of this stuff afterwards in the speakers area. Also in the afternoon coffee break, I'll be running Swiss Cyberstorm's very own facial recognition hacking corner. And you can come and try on some fake beards and wigs and masks and see whether you've come up with a foolproof recognition attack, if you like. But for the moment, let's get invisible. Here are some things that people have tried over the years to avoid detection. Here we have the most traditional recognition attack of all, obscuring the whole face, or the majority of the face, using a mask or a balaclava. This is a look mostly favored by hackers in stock photos. But some facial recognition systems absolutely can be fooled by masks. Even in 2018, you can still trick some of them with masks made out of printed pictures of the target's face. Late last year, Microsoft's Windows 10 Hello authentication system was discovered to be vulnerable to what's called a presentation attack, where it unlocks when it's shown a picture of the person that it's expecting to see. But they patched this, so of course none of us have machines that are vulnerable to this now because we all run the software updates as soon as they're available, right? Here's another one. This was in May this year, just a few months ago. This is the new OnePlus 6 smartphone. That face unlock function could also be fooled by someone holding up a picture of the target. Another traditional technique for avoiding recognition, favored by many celebrities over the years, is to wear sunglasses. Skewer the eyes. So, because your eyes and the bridge of your nose provide a huge collection of unique data points in a lot of traditional face maps. And sunglasses cover these things. They make it a bit harder to identify you. This doesn't always fool the facial detection step. Again, it really depends on the software that's running under the hood. Making weird faces is another way that facial recognition is sometimes fooled. Some software can't recognize you unless you're using a neutral expression. Passport photos and airport smart gates are in this category. I get tripped up by this a lot because I'm Australian, which means that I need to take very long flights to get to most places. And I definitely do not look the same as my passport picture of the smart gates after 28 hours in transit. The number of airport smart gates that have failed to recognize me because I was really, really tired is non-zero. In the realm of specialized anonymity fashion, we have the Paparazzi Scarf. This was created by a guy called Saif Siddiqui. His scarf project was inspired after a bicycle reflector ruined a photograph that he took when he was using flash. And then he realized that sometimes messing up a photograph could be really useful. So this scarf is mostly effective for ruining recognition that's performed on still images that were taken with flash. Apparently, Paris Hilton's been seen with one. But in case you're thinking of getting one, just be warned that the scarf in this picture will cost you about 450 Swiss francs, which is more than I have ever spent on a scarf, and is probably why Paris Hilton gets to have one and I don't. But for everyday people who don't have 450 francs to throw away on one scarf, you can get yourself one of these. This is a Paparazzi Visor. This became briefly popular late last year. It's advertised as a way to protect your face from the sun and also from annoying cameras. So much like a balaclava, it works by obscuring most of your face, although from all the reports that I've heard, it's kind of annoying to wear, and sunscreen does exist. But don't worry, this is slightly less annoying adversarial fashion. These are reflecticles. These work along the same lines as the Paparazzi Scarf, but for your face. Reflecticles are sunglasses with reflective decoration on the front of them. They work with visible light and infrared light. They have the added benefit of being a little less fashionably jarring to wear than the Paparazzi Visor. and they will make you look very cool in CCTV. So any survey of facial recognition attacks would be incomplete if I don't mention Adam Harvey's work. Harvey's an artist based in Berlin. He's mostly known for his CV Dazzle work. This is a computer vision attempt at the old warfare tactic of Dazzle camouflage. Just for a quick history lesson, Dazzle camouflage was an experimental form of painting used on ships in World War I. It wasn't intended to conceal a ship. This is obviously a ship. Well, it's a picture of a ship, but you know. But it made it more difficult to estimate things about the ship, like how fast it was going, its distance from you, and which way it was facing. This was supposed to make the ships harder to fire at, or for an enemy to predict things about. And the Dazzle camouflage method achieved this, as you can see here, by using huge blocks of color in irregular patterns on ships to break up their outline and their features. In just the same way, CV Dazzle will not make you invisible. To other human beings, it certainly won't make you invisible, unless you're at a sci-fi convention or a fashion show where everybody does this. But to computers, it will make it a lot harder for some of the older and the more common computer vision algorithms to recognize your face. It does this more or less the same way that they did in World War I, by breaking up a lot of the outlines of things that algorithms are designed to detect, mostly by messing with the patterns of light and dark. Harvey is also partially responsible for this. This is the HyperFace project. This is focused on making the parts of an image around the face more confusing for computers, instead of just focusing on the face itself. Patterns like this one aim to saturate facial detection algorithms with a bunch of patterns that it really wants to interpret as faces, and thereby stop it recognizing actual faces. So the idea is that you could make a shirt printed like this and wear it down the street and cause a bunch of computers to freak out. Outside of the realms of art and fashion, university researchers have also been trying hard to mess with facial recognition tech. Most of these methods are still very experimental, but some of them seem to be effective, and more of them are being developed all the time. Something that I haven't seen done for facial recognition quite so much yet, but which is definitely having an impact on other kinds of computer vision algorithms, is stickers. So a research team at Google discovered that these trippy-looking stickers will completely mess with a neural network trying to detect things in a photograph. In this case, the presence of this sticker in the image makes the neural network think that this banana is a toaster with a fairly high degree of confidence. I have not seen this tried with human faces yet. It is definitely not going to stop facial recognition techniques that are built on more traditional ideas about patterns of light and dark, or mesh creation. But if anyone's in the mood to conduct some research on this, there's a good chance that some kinds of experimental neural network-driven facial recognition tech will be vulnerable to this kind of thing. And like several of the other options that we've discussed, it's clearly something that will challenge ideas about fashion even further, which is never a bad thing. This is the one I'm most excited about, though. In a paper that was published in March, some researchers from Fudan University in Shanghai, they experimented with the effects of infrared light on facial recognition systems. So this team was able to demonstrate that beaming patches of infrared light onto your face in different ways can make some facial recognition systems think that you are someone else. They successfully got one system to recognize a member of their team as 4 different people using this method. And they did this with a small array of infrared lights that are mounted on the brim of the cap. These lights were programmed to shine on the face in different patterns, and they were enough to convince the machine looking at the image that that person was a different person. I really like this solution because the cap can be programmed to whatever you want. Infrared light doesn't bother you too much, and then when you're done with messing with facial recognition, you can just take the hat off and put it away. You don't have to spend time removing a lot of makeup or looking super suspicious with the visor. So academic research and fashion and art are all working together to come up with newer and stranger ways to defeat the newer and stranger algorithms that are being deployed. But honestly, the most effective way to combat facial recognition systems has nothing to do with facing the cameras at all. It's all to do with facing other people. The fact that the GDPR is now in effect in everywhere, but the fact that it's in effect means that a lot of companies in Europe Even if they're based outside of the EU, like here, they're forced to consider transparency of usage and get informed consent when it comes to deploying facial recognition tech. This is great for Europe, and I wish we had anything at all like this back home, but we don't yet. But even though the GDPR might make it more obvious to you when facial recognition tech is being used on you, it still doesn't do anything to guarantee that the underlying algorithms that are based, that the underlying algorithms are based on unbiased data sets, or that the accuracy of any of this tech has been in any way independently audited. And there's also the fact that in a global economy, non-GDPR compliant tech will absolutely still find its way here. And some companies are completely going to continue to use this stuff quietly because they think they won't get caught. Algorithmic transparency is still a complete pipe dream, but achieving it matters now more than ever in a world where Donald Trump is president of the United States, and every other day things just seem to get weirder and worse for nearly everybody. The GDPR doesn't mean that we can take a back seat and assume that the fight's over. We need to continue to ask questions, to talk to each other, and to be alert to the uses and the abuses of biased tech. We need to challenge the fancy statistics that we see when it comes to facial recognition accuracy, and ask ourselves if what we're hearing is marketing or an independently verified fact. Because right now, most of it definitely isn't unbiased, and most of it definitely isn't accurate for everyone. It's almost impossible to know which facial recognition solutions can really be trusted to be ethically responsible. As a final note, I'm not here to say that facial recognition technology has no place in the world. There are cases, like at international border crossings, where it can sometimes be useful. There are cases like unlocking an iPhone where it can sometimes be convenient. But there are also cases, regardless of the GDPR, where recognition is performed on us and used to draw conclusions about us that we don't have any real way to meaningfully interrogate, and we can't necessarily trust. So I'm here to urge caution in the way that these things are deployed, and to urge for the creation of more skepticism and more openness, better data sets, and clearer ways to know whose technology is being run under the hood. And if we're aware that facial recognition is going to be invisibly performed on us, in the absence of change from the top down, I would encourage you all to think about how you might become invisible to it in response. Thank you.
Brilliant talk, Lilly. Thank you so much. Here is Swiss chocolate for you for the long trip home.